Does. We're just about at 3:30 Eastern. Welcome, everybody. A couple more seconds. Okay. Welcome, everybody, to our 5 Steps to a 5 webinar on AP Calculus AB. We're about 6 weeks out from test date, so we've got a lot of material here that I think will be helpful. Before I hand it over to Emily Pilar, I'm going to cover just a couple of housekeeping things up top. Emily, can you click that slide, please?
Sure.
So before we get started, a couple things, just so we're clear, we welcome educators and students to these sessions, but they are primarily geared toward helping students succeed on the exam. So teachers, tell your friends, and your fellow educators, students, tell your friends, but just so you know, this is primarily a presentation that's aimed towards students at this point of the year heading into test day. The second bullet there, we at one point really wanted to try to limit the amount of questions we were being asked and we were going to shut off the chat feature. In real time, what we've noticed after doing a bunch of these things is that it works better if and when people do ask us questions throughout the session. Feel free to use the chat or the Q&A box. It's all good. If you've got a question, it's likely that someone else will have that same question as well. Participants won't be able to see one another. You should be able to see and hear both myself and Emily and Anya and Simone on the McGraw-Hill side are behind the scenes. You won't be able to see them, but they will pipe in as needed. So you should be able to hear them, but no one will be able to see one another. Importantly, in the blue box, and I know that both students and teachers have a concern, no student data is being collected at this thing. Right, so that concern you don't need to have that concern. We're not collecting anything. This is just a session for whoever wants to attend. The presentation is designed to be interactive. I think at some point, correct me if I'm wrong, Emily, but I think at some point we're going to have some polling with the multiple.
We're not going to do that for this presentation.
We're not going to do polling.
Yeah.
Okay. Regardless, it does help when everybody's involved. So if you have questions or if you want to participate, please do so. It makes the session a lot more enjoyable when people are participating. And last but not least, probably most important, is this session is being recorded. So please tell your friends, other teachers, other students in your school. It's going to be available on that bit.ly, that URL at the very bottom. By tomorrow, it should be up and live. I'll give you a couple seconds to take a picture of that with your phone, or jot it down on a piece of paper. But I think you'll realize as we go through, there's a lot of really, really useful information that's going to be shared on this thing. So please do feel free to send this out to others. And Anya, thank you. Anya put the URL, the bit.ly, in the chat box as well. With that, I'm going to hand it over to Emily. Emily is the author of our 5 Steps to a 5 AP Calc book. Emily, over to you.
Okay, great. Thank you. So just go through a little bit about what we plan to cover in this session. So I'll introduce myself and the subject matter. I'll talk a little bit about the actual exam, some really important things you need to know about the exam, and go through a couple of examples of what graders look for and some common mistakes and errors that students lose points on, particularly in the free response questions. Talk about some essential topics to review, both for the multiple choice and the free response. And then we'll spend some time going through some practice examples. Some are from the book, some are actual AP questions, both free response and multiple choice. And we'll have time for a little Q&A at the end, if not scattered throughout. So let's get into it. So my name is Emily Pilar. I teach on Long Island at Plainview High School, and I've been a calculus AB teacher since 2014. So when I'm not doing math and spending time with my 2 kids, I'm running. That's basically what I do. So let's get into it. I'll talk a little bit about the exam right now. So let's just break down the exam. There are 30 non-calculator multiple choice questions. So you're given 60 minutes for that. So think about 2 minutes for each question there. Then there's a calculator section, 45 minutes, 15 questions. So about 3 minutes a piece for those questions. And then there's 6 free response questions, 2 of which you're allowed to use your calculator on, and 4 of which you're not. And each of those free response questions about 15 minutes. Again, you have a total of 30 minutes, for example, for the 2 free response, but if you break it evenly, we get those 15 minutes apiece. So the AP exam, while it's not completely rushed, you definitely have to be mindful of time. In terms of exam weighting, it's 50% multiple choice, 50% free response in terms of grading. But in terms of calculator and non-calculator, you'll see 2/3 of it is non-calculator. So one thing I always tell my students is when you're practicing non-calculator questions, do not do it with a calculator. So I know your calculator can take derivatives, it can take integrals. You want to be practicing those skills appropriately. If it's a calculator question, practice it with a calculator. If it's a non-calculator question, don't be tempted, don't practice with a calculator. The 5 Steps to a 5 workbook has an approximate grade calculator in there. So if you take a practice exam, it's a really good way to kind of see where you're at. You can see how many multiple choice, how many free response, and kind of where that would land you. I also have a website included here that does the same thing based on different curve scales that are available. So that's a really great tool to kind of assess where you're at and see what you need to work on. Okay, so we'll talk a little bit about the multiple choice questions. The first thing, answer all questions. You do not get points deducted versus having it wrong versus not answering. You have to answer all questions. Don't leave those points on the table. You have a chance of getting it right if you guess it. Some questions, it's really helpful to work backwards. I'm going to go through an example a little bit later, but a lot of times students are okay actually with the calculus part and have a trouble with the algebra part of maybe getting their answer in a neat way that kind of corresponds to the multiple choice answers. So some of these questions we're able to work backwards. And again, I'll go through an example later, but plugging in a number for a variable that you get is a good way to kind of see, is my answer equivalent to any of these multiple choice answers if I plug in the same number for that variable. Again, as I mentioned before, you don't want to rush, but you do want to be mindful of that timing that I kind of laid out before. And a really important thing is to know your trig values of those major angles. For some reason, they love arctan of 1, that's pi over 4, that comes up a bunch too. Okay, free response. The first thing is that answers always have to be correct to 3 decimal places. So as you can see, here's an answer that I might get on my calculator. Here's 3 different correct versions that would be acceptable and an incorrect version. So what this basically shows you is if you round to the 3rd decimal place and it's incorrect, your answer is wrong. It's just as good as if you put 20,500 as if you put that answer that's really close but rounded incorrectly. What I always tell my students is not to worry about the rounding. You have plenty to worry about on this test. That rounding should not be the thing that you're focused on. So I really like to truncate my answer. I'm going to just point it out here. I like this version here. To truncate my answer to 4 decimal places, which means don't worry about rounding, write 4 decimal places down, and that answer will be correct. Okay, so after the 4 decimal places, don't even think about rounding, just write it down. That answer will be acceptable. That kind of eliminates the chance for rounding errors. In terms of rounding, you don't want to round to the end. So if your answer has to be correct to 3 decimal places, anytime you're kind of using a number going through, make sure you're not rounding until the end. Leave all those decimal places. We're kind of going to go through an example later. I'll show you in the calculator. Show all work. If your calculator is used, you have to show what you plugged into your calculator. And don't waste time simplifying answers. So all of these things that I wrote here are acceptable. 90 over 9, we know that you know it's 10, but if you for some reason wrote 11 because you're rushing, then it's wrong. Don't simplify it. Even when I have the 2 times 3 minus 6 over 2 times 3, that's totally acceptable. Cosine of 30, believe it or not, is acceptable. Something that you could just type into a scientific calculator and get a number is all acceptable. All these answers do not have to be reduced. Make sure that if they ask for units, you give them. So that's going to be worth a point on a free response question. Look for if they say put units there, you have to put the units. If you don't know, at least guess, have some units there. The word justify comes up a lot in these free response questions. So showing just a graph or a picture is not enough of the justification. You need to write a sentence. It needs to involve words. The only real exception that I've kind of seen would be using the candidate test from absolute maximum or minimum. And I'm going to actually go through an example later to show you how that justification will work. But otherwise, if you're using little line graphs, you need words to describe it. The word it is here on out, banned from your vocabulary when we're talking about free response questions. The reader does not know what it is, okay? Using words like even the curve, the graph, the function, the curve, what graph, the what function. So if you're going to use words like curve, graph, and function, those are okay, but be specific. The graph of f prime, the function f double prime, the curve of f. Okay, we don't know what it is, but we can use the words in the parentheses, but make sure we're going back to which function we're talking about. The next thing is a standard test taking practice. If you made a mistake, just don't waste time erasing it, cross it out, and kind of move on. And then the last part, don't let the beginning of a free response prevent you from answering the later part, because sometimes these free response questions, they're even completely different units from part A to part D. So just because you can't answer something in part A doesn't mean you can't get all the possible points from B, C, and D. So maybe skip it, move on, and come back to it. Okay, so something called a linkage error is a very, very common error that happens in these free response questions, and it causes a lot of people to get points off where they may understand the math, know the calculus, but it's the way they represent it that gets them the points deducted. So for example, this first line is an example of a linkage error. So let's say in a problem, you know you have to multiply 40 times 5 and then divide it by 2. If you wrote it out as I have here, 40 times 5 equals 200, divided by 2 equals 100, that's a linkage error because 40 times 5 is not equal to 200 divided by 2. You want to write it as a separate line. So if you know you have to multiply 40 times 5, write that equals 200, then have a new line and say 200 divided by 2 equals 100. This comes up when we work with limits. An example I'm going to show you later of I'll kind of come back to this term so you can see another example of what I'm talking about with linkage errors. But just be careful. If you're writing an equal sign in between, those things have to be equal. Okay, calculator, make sure you're in radian mode. Do it right now. Go to mode, make sure you're in radian mode. That's what we stay with in calculus. And know what work to show if you're using a calculator. And again, I'm going to go through a free response question in a bit that involves this. I have an example here. So if you have an acceleration function of a particle that's given with this velocity, and you want to find the total distance, right? We know we'd have to integrate that velocity function, the absolute value of it. If you're typing that in your calculator, this is what you want to write. So you want to write the actual thing that you're typing in your calculator, is what I'm getting at. You could write v of t. You could also write in the actual function. Either of them would be acceptable. Okay, another thing that we need to know how to do would be storing values. This is particularly useful when we're talking about volume and accumulation function in free response questions. I'll go through this example a little bit more quickly because I'm going to walk you through an example with the calculator and how to do that later, but it's just kind of a key skill. So if we want to find the area in this region over here, all right. All right, in this region right here, right? We're graphing this. I like to store these two functions in y1 and y2. And we're going to need to find this intersection point in order to find the area of this region. And so the stow button on your calculator is something that's very useful. Again, I'll show you this in a bit of how to do it. You want to write down what the value is of that intersection point, but also store it in your calculator. So you only would have to type this in rather than typing out the functions because they're already stored into y1, y2. On your paper, which is what I kind of want to emphasize, is you can write it like this. You can write it like this. Either of those are acceptable. You can write the value in for A, or if you're telling them what the value is of A, you can just simply write A. So there's a lot of shorthand that I know it seems kind of small, but when you're doing these long free response questions are really helpful. Let's see, next, if we want to have the volume, something similar, right? So the volume of this, we would do our washer method, and this is what you only have to type in your calculator. You can write it like this. You can write it with your f of x and g of x, but as long as you're writing out these integrals that you're typing in your calculator, you can receive full credit. Okay, another kind of list of things you need to know how to do in your calculator. We have to know how to solve an equation. You can use your calculator for that, right? We can either plug each side of the equation into y1 and y2 and find the intersection point. Or you can have, if the equation is equal to 0, you can plug that into y1 and see where the function has a 0. So we need to be able to find intersection points, max and minimums, or zeros in our calculator. So using that second calc. Sometimes I find it useful to change our window, the domain and range if necessary. It helps you kind of see the graph better. So for example, if I had a graph like this, and this is the only region that I'm calculating the area of, I would probably change my window from like -1 to, I would kind of change it to just see this region a little bit more clearly. Also math 8 and math 9, finding the derivative and finding the integral too. Okay, so now I'm going to go through a couple of examples of questions where two student sample responses, one of which would receive full credit and one of which would not. So I find it useful if maybe you can kind of think about where the student lost credit. Okay, so this is a differential equation. Okay, so if we look at it, the student added 2x to both sides, factored out our x, kind of cross multiplied to get the dx over here, divided by y plus 2 to result right here, and took the integral. Then raised these two sides to the e, and we're left with y plus 2 and ae to the x squared over 2, subtracted 2 from both sides, plugged in our initial condition up here, which led to a equals 3, and found the answer. So think about if you can spot where the error is, a very common error, and that would be, right, when we take the integral, we cannot forget the constant here. Okay, it specifically says on the scoring guide that this constant is necessary. You can write it on both sides, plus C1 and plus C2 on both sides, but as long as you have it at least on one side, you're good to go. The other thing that is super important is if you are totally lost on a differential equation, the number one thing that you want to try to get to is the separation of variables. You want to try to get all your y's on one side with a dy and all your x's on the other side with a dx. Specifically in the scoring guide, anytime we have a differential equation, if students aren't able to separate the variables, they do not receive any points. Okay, so even if a lot of you get something and then the integrations, there's things that are correct in the problem. If you can't first separate the variables, that's the issue. So you want to spend time making sure the variables are separated on every differential equation problem that you get. Okay, let's look at example number 2. So we have a particle moving along the x-axis. Here's our velocity, and we want to find average velocity. So we see that term average come up in a lot of problems. So here's our student 1. They found the velocity at 10, they found the velocity at 0, and they took the average. They added it up and divided by 2. So my hint here is that you will never do this kind of average in calculus. We've done this average all along. For some reason, when we get to calculus, we don't do this type of average anymore, taking it up and dividing by 2, unless you consider area of a trapezoid, that type of average. But for the most part, this type of average is not done. Okay, when we are given velocity or any function for that matter, and we want to find the average of that very function, we have to use our average value formula. 1 over b minus a, the integral from a to b of the function. Notice how I truncated it after 4 decimal places. I just cut it off. Again, that's what I like to do. So here are 2 kind of averages that come up. Average rate of change and average value. So if we want to, for example, find an average acceleration. Let's just use a different problem, average acceleration. If we're given acceleration, we would use this. So if you want to find the average of a function that you are given, you use average value. If you want to find average acceleration and you are given velocity, we are going to use average rate of change because we're talking about the derivative of velocity, right? So if you want to find average acceleration and you're given velocity, we would use something called the average rate of change. We have to know when to use these 2. You're never going to do added up divided by 2. It's going to be one of these 2. And our next example comes from another particle motion problem when we're given velocity and we want to find maximum acceleration. So this student found the acceleration function by taking the derivative of velocity. Now found the derivative of that function because we're trying to find the maximum acceleration. So we want to find the critical point, which is when the derivative equals 0. So they found the critical point of t equals 4. Since we want maximum acceleration, they plugged that value into the acceleration and found that the maximum acceleration is 0. This is not full credit. When we talk about the maximum acceleration, they're talking about the absolute max. Anytime we're talking about absolute, we want to do what's called the candidate test. And I remember I referenced this earlier. When we say justify your answer, this serves as a completely fine justification. So not that many words going on here, but this chart does serve as a justification. So what we have to do is we have to test the critical points, which is 4. We also have to test the endpoints. So we have to plug in 0 and 7 as well. And as you can see, the maximum acceleration is actually 16. It turns out that the minimum acceleration is 0. Another thing I want to point out, when we're talking about relative max and min, typically the AP is looking for at what values those occur. So what X values, or in this case, what T values. When we talk about absolute max and min, they're looking for the Y value. They're looking for you to find where it occurs and plug it back in. So we're giving our Y value or our value of acceleration here, not where it occurs, but what the maximum is. Okay, moving to example number 4. We have a function here, twice differentiable. And we want to find the fewest number of times that the derivative must equal 0. So this student says by the mean value theorem, L prime is greater than 0 for somewhere in between 1 and 3, right? Because we can see it goes from 156 to 176, and from 4 to 7, it increases here as well. And the derivative is less than 0 in between 3 and 4 at some point, because it's going down, and between 7 and 8, again, for the same reason. Therefore, by the intermediate value theorem, that the derivative has to be 0 at least 3 times. Think about it. If it goes from a positive number to a negative number to a positive number to a negative number, it has to be 0 at least 3 times. So what the student did not receive full credit for was they didn't state the preconditions or the hypotheses needed for the mean value theorem. We have to state that the function is differentiable on the closed interval, therefore it's also continuous on the closed interval. So when we talk about our 3 theorems, right, I have them listed out here: extreme value theorem, intermediate value theorem, and mean value theorem. If we're ever going to use these in a free response question, you want to make sure that you're stating the hypotheses before you use those theorems. Extreme value theorem has to be continuous on the closed integral. Intermediate value theorem, the same thing. And we're trying to get a y value that's somewhere in between the y values at the endpoints. The mean value theorem, you have to say is continuous on the closed interval and differentiable on the open interval. A lot of times the problem will give you, for example, when we're using the mean value theorem, that it's differentiable on a closed interval. Therefore, we can just infer that it has to be continuous as well. So those two can be stated. A lot of times they will give you this part, and then we can infer that it's continuous. Or they can give you that the function is differentiable on a closed interval. And if we're using intermediate value theorem, if it's differentiable, it has to be continuous. We can kind of use that there. I put Rolle's theorem here as well if you're going to use that, but we can always just use mean value theorem. There's also some hypothesis or preconditions needed for L'Hopital's rule, but I'll discuss that later. They are pretty specific about what's needed to be said in order to use L'Hopital's rule. All right, we have a last example here. This is number 5. Another particle motion question. This particle moves along the x-axis with this velocity. Is the speed of the particle increasing at t = 3? A popular question, but more importantly, a popular question that students get incorrect. So this student found the acceleration, plugged in 3 here, okay? So here's our acceleration function. When we plug in 3, we get e to the -2. Remember, that's really 1 over e squared, which is a positive number. E raised to any power is positive. So this person said the acceleration is positive, therefore the speed of the particle is increasing. This is not correct. This means only that the velocity is increasing. Remember, the sign of acceleration tells us if the velocity is increasing or decreasing. It does not tell us if the speed of the particle is increasing or decreasing, i.e. if the particle is speeding up or slowing down. What we need to assess is the signs of both acceleration and velocity. So here, the student, again, found the acceleration function, plugged in a = 3, and found that the acceleration is greater than 0. They also plugged in 3 to the velocity function and found that this is the velocity. So this is also a little bit sometimes hard for students to assess if that's positive or negative. We have a -1, and we're subtracting off e raised to anything is a positive value. So if we have -1 and we're subtracting off another positive value, it's just going to be more negative. This is a negative value. We don't care what it is. We just know it's negative. So now we can look at this. Acceleration is positive. Velocity is negative. The particle is actually slowing down. The speed is decreasing because acceleration and velocity have opposite signs. So a question like this, when we're giving a reason, don't go into an extremely long paragraph, right? If you keep going and something you say is you have the right answer, but then you also say something that's incorrect, now points are being deducted, okay? We're simply looking at the signs. One sign's positive, one sign's negative, enough, we're done. Okay, so make sure you're answering the question, but don't keep going further than that.
Emily, just a quick, perfect timing.
Yeah.
Just a quick time check. We're just closing in on 30 minutes.
Okay, great, thank you.
About a third of the way through.
Perfect. All right, so let's talk about some of the topics that would be important for reviewing. So multiple choice, the 2 topics with the greatest exam weighting for multiple choice are applying derivatives to analyze functions and integration and accumulation of change. And then I've broken down the free response topics into kind of 5 different topics. If you look back over the past years, and I definitely suggest doing this, I'll talk about that actually in the next slide, of old free response questions. If you do a bunch of these, you see they keep kind of repeating themselves in the overall topic. So we typically have an area volume question, some type of accumulation, net change type of question, particle motion question, differential equation question, and something that relates f to f prime to f double prime, or a function defined by an integral, something with this for the graph. Some of these we're going to go through. Some minor topics are also related rates. Sometimes these are like mixed in with the other question. L'Hopital's rule, since it was introduced into the curriculum a few years ago, has been popping up in like one part of a free response question, including the diameter limits and Riemann sums. So that those do come up, but those are the kind of 5 main topics. So what should we do to study? So now we're about 6 weeks out. So some suggestions: take a practice exam. You know, the book provides 2 great exams. Go through it, simulate the test, grade yourself, see where you're struggling. Are there some specific areas that you need to go back and review those chapters? Take some time to kind of go back through maybe the chapters that you're getting these questions wrong in. Answer the questions in these chapters and grade yourself. I really think grading yourself is a great way to assess where you're at. If you go online, just Google AP calculus free response questions, all the scoring guides come up, and you can kind of do a question and use the scoring guide to see where you're at. Use this time to make a study guide for yourself. Making a study guide helps you, go through all the topics, pick out the key ideas that you need. 2 weeks before the exam, maybe take another practice exam, see if there's still some areas you need to work on. Review your study guide, and make sure the night before, don't make yourself crazy. If you're spending all this time, we're 6 weeks out, you have plenty of time. The night before is not the time to be cramming. It's right now. So if you're kind of pacing yourself, that's a great strategy. Make sure you have all the supplies necessary for the exam. That would be a pen, a pencil, a calculator. You're allowed to bring a watch, which is a great idea. It just can't be one with internet access. So kind of for pacing yourself, maybe a snack. Make sure you get a good night's rest. Okay, so now we're going to go through some practice questions. We'll start with some free response questions, and then we will get into a couple multiple choice questions. I'll show you what graders look for. I'll show you how we write out these justifications. I'll show you some tricks on the calculator as well. Some shortcuts that would save you time too. Okay, so here's our first question. This is an area volume question. Give you a second to get over.
For those of you attending live, it's real easy to click and drag the poll over to the side. So if it's blocking the question or the graph.
So calculator here as well. So this would be a calculator active question. So the first thing I'm going to do when I see this question is I'm going to plug my 2 functions, 2x to the 4th minus 5x in my graph, and 4x minus x squared. So this question actually gave me the graph, but we might not be so lucky to have that. So let's graph it here. Okay, so here's my graph. I would probably change my window. Let's go from like -2 to 5. I'm just going to change the x from -2 to that. I'll go to 6. Just to see it a little more clearly. Okay, so there's my region right there. So let's go to that first question. We want to find the area of region S. So if we want to do that, we want to find the integral. And actually, sorry, I want to write down what's y1. Here's my y1. So I would probably just write y1 is 2x to the fourth minus 5x cubed, and y2 is 4x minus x squared. So now when I go out and write my integral, I don't need to write out this whole function. We get kind of caught up in those parentheses. So just writing that out to start is great. So we have the top function minus the bottom function. So y2 is on the top minus y1 dx. And we're going from, let's look at the graph, this intersection point to that intersection point. So it looks like this is 0, but I'm just going to double check it is. So I'm going to calculate the intersection point. Remember, left and right arrows move along a curve, up and down moves between curves. Right, so enter, enter, enter. That's my 0. Okay, so that goes from 0. And now let's calculate the other intersection point. So if I'm going to move over, right, so there's my value. I'm going to write this value down as A. So it's 2.6030784. I'm not going to be stingy with my decimal points there. I want to write them all out. And then when I'm going to store this value. So if I hit quit, if I hit this button stow, I'm going to store it into A, so I don't have to type it ever again, right? I'm done typing it. I'm writing A right here. It's shown right there. So watch how easy this is now. If I hit math 9, 0, now A's already in there. Y2 is in there. I can go Y2 minus Y1 and dx, and I have my answer there. So it would be 17.2580. There's my 4 decimal points. I'm not going to write anything else. So again, you're taking a little bit more time up front with storing the values, but watch how it helps you later in the problem. And you don't have to be so careful with the parentheses you're putting in your calculator, because you're just having y2 and y1 recalled right there. Okay, let's move next. We're evolving, making a solid here. I'm going to actually type in the new function y equals 4 just to kind of get an idea of what it looks like. So there's that line there. So my line goes across here. So I'm revolving this around that line. Okay, so as you can see, there is some space between my axis of revolution and my area. Therefore, it's going to be the washer method. And if you remember, it's pi big R squared minus little r squared. And we're revolving it around the line that's horizontal, meaning it's a dx. So we're going from 0 to A, and we need our big radius squared minus our little radius squared dx. So how do we find the big radius? I always put my point on the axis of revolution, and I draw a line all the way till I hit my outside of my region. There would be that would be big R. And little r is from, it doesn't really matter where you're drawing this, here to the first time I touch my region, which is there's little r. So big R, I do top minus bottom. So the top part is 4. The bottom part is my y1. Right, I'll remind you this was y1, y2. And then the little r, the top function is 4, and the bottom function on my curve would be y2, and I can type that right in my calculator. So again, what I'm writing here is totally acceptable on the AP, right? Because we've specified what A is. We've specified what y1 and y2 are. So we're good to go. Squared minus 4 minus alpha 2 squared dx. Forgot my pi, right? So times pi. And 543.1698. Again, I'm not worrying about rounding. I'm writing 4 decimal places, moving on. All right, now we have a cross-sectional volume. So the volume is going to be the integral. And we're going to integrate the area of the cross-section. I notice a lot of times these will say if it's taken perpendicular to the x-axis, perpendicular to the y-axis. A lot of times I use that vocabulary. Perpendicular to the x-axis is dx, the y-axis is dy. All right, again, we're going to 0 to a. Here's the height of my cross-section. Okay. And the other one is in the plane there. So that would also be top minus bottom, which we said was y2 minus y1 dx. So if we do not alpha, sorry, math 9, 0 to a of 0.5 plus 2x and y2 minus y1 dx. We get our area here. And again, 4 decimal places, not rounding. Okay, so there would be our area of volume question. Okay, need a second to read this. Basically, we have customers removing bananas from a display according to this. According to this function, employees adding bananas to the display according to that function. I'm going to put those in my calculator. It's not always necessary to put this in a fraction, but you can do it divided by. I love my functions to look as close to actually as they appear, because you don't want to just enter something wrong. So having that fraction allows me to see. Okay, so let's go to the first question. Okay, this is a very common type of question. Something's being added, something's being taken away. People are going in line, people are getting out of a line. Bananas are being added, bananas being taken away. There's very common, whether they're both given as functions or, you know, water's flowing into a tub with certain function and coming out based on a chart. You'll see if you keep doing practice questions, this type of question is very popular. So how many pounds of bananas were removed from the display during the first 2 hours? So here's our function that described the rate at which they're removed. So if we want to find the total number removed, we have to find the integral. And since they already tell us that that's f of t, all we have to write is the integral of f of t going from 0 to 2. Okay, so you don't have to rewrite the function. And again, since it's in there, if we hit math 9, 0 to 2, my f of t was y1, so I can hit y1 dx. That would be okay, how many times? That's all you need for the answer. No explanation there. Okay, now we want to find the derivative. Again, your calculator finds the derivative, so that's not necessarily the difficult part, but we're going to talk about the explanation. So if we just hit math 8, we can find the derivative of our y1 function evaluated at x equals 7. So that would be negative 8.1. So number one, we want units. So if f of t is measured in pounds per hour, when we take the derivative, that adds on another per hour. So we can write it like that. We could write pounds per hour squared if we want to, but remember, taking the derivative is going to add another per hour. If we integrate, we would get just pounds like we did in part A. Explain the meeting. So if this is the rate at which the bananas were moved from the display, when we take the derivative, that's the rate at which this rate is changing. Okay, so what we want to do is we want to bring in the 7. So a good explanation for this would be after the store is opened for 7 hours, the rate its bananas are being removed decreasing by 8.1195 pounds per hour squared. So just keep in mind, if you're saying decreasing already, don't also put in the negative. That would kind of be a double negative. So you can say is changing by negative 8.1195 or decreasing by the positive value. Okay, so if we move to the next slide.
Sorry, Emily?
Yeah, can you hear me?
Yeah, I can. I just before you move to the next slide, we did get one quick question request. Rhonda's asking, when you get the chance, can you go over how to store a large decimal as a letter? Please.
Yes, okay. So let's just look here. I'm sorry, my computer froze for a second. Huh. Sorry, my screen is frozen. Can you still hear me?
Yeah, we can hear you, but it
I
is
can hear you.
screen does seem frozen.
My screen is frozen. Okay. I don't know what it is.
Maybe you want to exit and come back, or
I guess I'm going to have to try that.
you know what, Emily, you there?
Sure. Yes, I'm here.
If you can stop sharing and send it over to
Yes.
me, and I'll start the share. Maybe we can jump ahead to do maybe that's one way to see. If I start sharing, then I stop and back to you. Maybe that'll help. If not, maybe we
Okay.
can
I
jump
can't
ahead
even
to
get
my
out.
section.
I can't even get out of anything here. Yeah, I can't even stop anything.
Anya, do you have the slides?
I have the slides, yes, and maybe we can go over the online course, and Emily, you can just restart your computer.
That's what I
Okay.
was gonna say, maybe.
Okay,
And then come back
wait, I'm gonna restart it right now.
into the same link, yes. One
Okay,
second.
all right, thank you.
Emily, if you can stop sharing, I don't know, I guess you can't, right? You won't be able, Anya, you won't be able to share unless she stops sharing. Sorry, everybody, technical difficulties. Should be just another minute or two. Thanks for your patience.
Emily, you may need to force quit. Oh, okay. I just sent the deck over to you.
Got it.
If I could start right now, I'd send my money.
Oh, yeah, so maybe you need to take a look at that.
Okay.
Anya, can you see that on my
Yes.
screen? You can. Can you just see if you guys, other people on the meeting can see this, just give us a little check mark or something in the chat. Look good, Anya?
Yep.
Okay. So I'm going to jump ahead to the online course. So by attending this course, you guys have access to our online portion for the AP Calculus AB. If you take a minute to a couple seconds to take a photo of this, this is the URL that's going to get you in, and the access code, which will allow you to access the AP Calculus AB portion. I'll leave it here for a second. Take a picture. I think we'll try to show it again at the end. So real quickly. Sorry, I wasn't planning to do it this soon. Nope. You're good, Emily?
I'm good, I'm back whenever you need.
All right. Now that I'm here, we might as well spend some time, a few minutes. So the first thing you'll see when you log in, first of all, just a quick note on the login. When you go in with your access code, it's really easy. It'll take you about 30 seconds to sign up. It's your first name, last name, and an email address. Please don't be concerned about putting your email address in there. We're not going to spam you. We're not going to, you will get exactly one email from us just to verify that you've signed up for the free course. Once you get in, the first, Emily, what's the date of the test? May?
It is May, I should know this off the top of my head, right?
Sorry to put you on the spot there. It's probably, let's say it's May 3rd. I'm going to make a guess. The first thing you'll see when you come into your study plan will be, it's going to prompt you to add the day of your test. I'm guessing it's May 3rd.
May 8th, I think
May
it is.
8th?
Yeah, May 8th.
Okay. May 8th, all you do is click that on the calendar, press continue, and you've got an updated study plan. So we're now currently 47 days out from test date. Every time you come back in, it will update. A couple days from now, it's 45 days, and it will update automatically every time you log back in. One of the cool things about this online platform is if you're doing it on your laptop in school and you get up to question 12, and then you have to leave, you get on the bus and you log in on your phone, it's going to pick up on question 12 or 13. No matter what device you're on, it's going to read you and update as you go along. So my advice here is to take some time and go explore this online course yourself. I'll spend about 5 minutes showing you the highlights just to give you a taste. But really, if you want to do it justice, go in and spend some time in there yourself. So again, it's 47 days till test date. This percentile rank, my average score on practice questions, my average score on tests, and my process of everything from pre-calculus through limits and areas and volume all the way through the end. This will all update in real time as I go through the program. So the next time I come in here, it's going to show me my average score, where I am in the program. It's kind of a cool feature. You can just go through the study plan, which reflects everything in our 5 steps to a 5 guide. Start wherever you want, jump into the things you have most trouble with, or start from the beginning. And I mean, it's really designed for you to do the whole course, starting from the beginning and go through the end. I think in real life, people rarely use it that way, but you can feel free. It's going to personalize to your strengths and weaknesses. There's a game center, some pretty simple flashcard based games, just a gamified way of going through some content. You're on the bus or you have some free time at school, you can jump in here and play some game. It's still going to reinforce the concepts of AP Calc. There's a discussion board. These are kind of rarely used. Every once in a while, you'll see some students are coming back, hey guys, what's the derivative of EX? Or you'll often see something like, hey, on question 12 on practice test 1, is it C and not D, or what did you guys get? For the lessons, there's a self-guided, again, way through these. If I say I want to do applications of derivatives, it's a nice short chapter. Go in here, read these things. I'm going to rate my confidence high on the things that I know. Related rate problems, common related rate problems, inverted cone problem. I know those. I'm going to rate myself high. When it comes to applied maximum minimum problems, distance problems, I'm not really sure. I'm going to rate myself low. So the next time I come back into my lessons, I log in a few days from now, I'm going to see the ones that I rated myself low. And those will be the ones that I know I marked to revisit, that I need to go back. The stuff that you know, you probably already know. If you don't and you rate yourself low, it's going to prompt you to go back and review. The flashcards to me are worth it alone for signing up for this thing. It's 180 flashcards. Again, if you're on the bus or have some free time in study hall, 1 click and it gives you the answer. Did you get it right? No, kinda, or yes. Again, use these to sort of indicate whether or not you'd like to come back to them. Slope of a line, got it. Cosine 360, didn't know that one. I'm going to come back to it later. The ones you mark as no or kinda, you'll see again. The practice questions are a really good resource. You've got in differentiation, you've got 39 questions in here. You want to practice it, you can either go through with the reviewing the answer turned on or off. I think in this portion, most people will do it. I have no idea what the answer to this is. So I'm going to write my answer here. I'm going to say 1.2. Not even close. It's probably supposed to be a letter. And there you go. So I'm not going to spend too much time in here, but you will see the answer as you go through in these, and it'll show you the answer as you proceed through the thing. Probably the most important piece of this thing is there are 3 full-length practice exams. And like Emily said, and most teachers will tell you, it is a really good idea to sit for a full-length practice exam before you go and take the AP exam. Even if you're the most confident and you know you got it locked down and you're sure you're going to do well, it's still a good idea. It's a 3-hour and 15-minute test. To do it at least once, start at the beginning, go all the way through, answer the questions, dedicate the time, sit and concentrate for the correct amount of time. So you're at least used to doing it all the way through. And there's 3 of them here for you. A diagnostic, which you can use when you first get in, and 2 other full-length Calc AB exams. I'm not going to spend any more time here. I'm going to come back and let Emily share to go through the rest of it. But I would urge you guys, please do feel free to share this. If you're a teacher, share this with other teachers in your school, students, tell your friends about it. We love to get more eyeballs on this thing, and it's a really good study tool.
Okay, I'll share my screen. So I'll go back to the question that was asked of how to store those values again. So let me show you what I just had. I still have the functions in. I just calculated the intersection point. So once it gave me the intersection point, if you just quit out of there, and now that's in your answer. So if I just hit this button here, stow, that puts that intersection point into any variable I want. I like to use A because it's right up there. So I hit alpha A and hit enter. So now that intersection point, is it still there? No, it doesn't show me anymore, but that intersection point was 6 point this number here. So again, if you just type A, that value is an A. So again, if you just have the intersection, hit stow, alpha, whatever letter you wanted in. And if I come back to this question, they want to know if the number of bananas is increasing or decreasing at this time. So if we think about the rate at which the bananas are being added to the table, that would be G of 5. And they're being removed at this rate. So we're just basically figuring out, is this number greater than or less than 0? So we want to, in our calculator, do y2. So this is a great kind of shortcut. If you do y2 of 5, that's G of 5. Actually, I should just do them together, right? So sorry, let's quit. Let's do y2 instead of typing out the whole thing, right? I'm all for the shortcuts when we get to our free response, minus y1, as long as you're remembering which is which, that's going to give you that number. That's all I have to write on my paper. That's all I have to enter my calculator. No complicated parentheses or anything. So we know this number is less than 0. So that means the rate. So the number of bananas is decreasing. So let's look at the next one.
Did that answer your question, Rhonda, about how to store a large decimal, or are we getting to that?
That was the calculator part.
Thank you.
Tell me if I didn't answer it. Is that okay?
Great, looks great to me. If Rhonda, if you have any further questions, feel free to ask. But for now, there she said yes, it did. So thanks, Emily. Great.
Okay, no problem. So the number of bananas. Okay, we started out with 50. We want to find how many were added to the table. So we're adding at a rate of G of t. So the total would be the integral of that. We're going until time 8, but notice that they only start adding at t equals 3. That's where they might get you. We're taking it off at a rate of f of t, but we want the total, so we integrate. That starts at 0, right? That starts at 0, but we're only going to t equals 8. I forgot my DTs, which I need to go here. That's all I need to write. And again, my answering, so math 9, 50 plus 9. We're going from, 3 to 8 of my G was my Y2. And for X minus, and we're taking away from 0 to 8. And I'm doing my 1 for that one. Dx. Okay, so 23.3473 pounds. You tell me how you get 3,473 pounds of bananas on a display. I'm not sure, but that's our answer, right? We need the 4 decimal places. Okay, this one is a non-calculated problem. So let's get rid of our calculator. This is a very popular type of question. We're relating f to its derivative and its second derivative. And I'm going to show you all the no-nos that we can't have. So f of -3 and f of 3, that's pretty straightforward. F of -3, we're just plugging it into our function. So we're going from 0 to -3 of g of t dt. Notice when you're evaluating an integral based on a graph, you always want the smaller number to be on the bottom. So we're going to switch it, make it negative. Okay, so we have our negative and we're going to do the area. So from -3 to 0. So from -3 to -1, that's our area here. It's a triangle. So 1/2, the base is 2, the height is 2, and it's below the x-axis. So it's negative. Then we're going with this area here. Above the x-axis, it's positive. It's a triangle. 1/2. Here's our base. Here's our height. What's the beautiful thing about this? I do not do anything. There is my answer. Please don't reduce it. If you reduce it, you can check your answer. It's 1, I promise you. But on the AP, the thing I boxed is a fully acceptable answer. Now from f of 3, right, we plug this in here. We're going from 0 to 3. So here's our first triangle. It's above the x-axis, so it's positive. 1/2, the base is 1, the height is 2. Then here is our next triangle. It's below the x-axis, it's negative. Its height is 1 and its base is 2. I do not want to simplify this. Don't get off for algebraic mistakes. It's equal to 0 if you want to check your work, but leave it as I was boxed it. Okay. We want to find where f has a relative max or min. I have a little chart that I love that really helps me when I do these types of problems. So if we have f, f prime, and f double prime, I like to write plus minus, increasing, decreasing, concave up, concave down. Now for f prime, we just shift over. Plus minus, increasing, decreasing. F double prime, we shift over again, plus minus. What does this mean? F is concave up, where f prime is increasing and f double prime is positive. Pick a random one. When f prime is positive, f is increasing, right? These columns kind of help us relate it. Here, f is the integral of g. So f prime is the derivative of this integral, or just g, and this is g prime. This helps me relate all these questions. I'm looking for a relative max or min on f, which is here. So I have the graph of g. So I'm looking here where it switches from positive to negative or negative to positive. Where is that? That would be at the zeros. So at x equals -1 is a relative, well, it's going from negative to positive. So it's a relative minimum. Because f prime, which is g, switches from negative to positive. Nothing else is needed. Students tend to go on and on and on about these. That's all that's needed. F equals 1, g goes from positive to negative. So it's a relative max. Prime, which is the same thing as g, switches from positive to negative. And that's all we need. So that chart again can help us with this problem as well. We want to find where f changes concavity. So if we look, f changes concavity is right here, where f prime goes from increasing to decreasing, or it would be vice versa. Okay, so if we go to the next page. That happens here and here. At x equals 0 and equals 2, because f prime, which is g, changes from increasing to decreasing or decreasing to increasing. Okay, we can see something about f double prime or g prime changing sign, but we have to relate it that it's the slope of g. So we can say the slope of g or f double prime changes from positive to negative and then negative to positive, but you have to relate all those things to get full credit. Okay, write the equation of a tangent line. So tangent line, I always like to do point slope form, right? So y minus y1 and x minus x1. Okay, so we know here's our x value is 1. What's our y value? So to get our y value, we have to type in f of 1. It's the area under the curve from 0 to 1. 1/2 base times height, which is just 1. So there's our xy coordinate. And our slope would be f prime of 1, which is the same thing as g of 1. G of 1 is the y value here, which is 0. So we have y minus 1, 0, x minus 1. You can leave it like that. We can reduce it. It's y equals 1. Here, I just want to touch upon just a brief thing. So instead of doing this whole free response question, I just want to focus on this L'Hopital's rule, because you have to be very careful about what you are saying as the preconditions before we use L'Hopital's rule. So here we want to evaluate this limit. So here is our function defined by an integral. So if you look, right, we want to evaluate both the top and the bottom. Let's look at the bottom function. If we plug in 2 here, we got 2 squared minus 2 times 2, which is equal to 0. Notice how when I plugged in 2, then I can get rid of my limit. You cannot get rid of the limit before or after. Here, it's kind of a little more straightforward. I'll show you more about that later. Now let's also look at the limit as x approaches 2 of g of x. Right? And we can say because g is continuous, this is equal to, right, if we plug in 2, and the area from 0 to 2 is equal on the top and bottom. So the area above minus the area below is going to be equal to 0. We have to make sure that we say because g of x is continuous on, and we're going from -4 to 6, and we have to show these limits separately before we use L'Hopital's rule. So it is the indeterminate form of 0 over 0. So using L'Hopital's rule, now we can show the limits. So again, we have to show the function's continuous. We have to show the limits of the numerator and denominator separately before we use L'Hopital's rule. Now here's where I was saying I was going to come back to that linkage error. So if we take the limit g of x over x squared minus 2x, that's equal using L'Hopital's rule to the derivative, we still need the limit. Do not forget to keep your limit in there until we're plugging in for x. So I keep the limit again. Now g prime is the same thing as f. I'm going to switch it out, but I'm going to keep the limit. Now, when I plug in my 2, I can eliminate the limit. It's 2, right? F of 2 here. Here's f of 2 would be -4. And I'm not going to, even though I'm pretty confident I can get what that denominator equals, I am going to leave it like this. Once I evaluate f of 2, I'm done. This is equal to 2, trust me, but you don't need to reduce it. Okay, so be careful of these linkage errors. Keep your limits in there until you plug in the value for x. Once you get rid of your x, you can eliminate the limit. You can't just say this limit equals this value. You have to keep the limit in there until we plug in our 2. Okay, I want to go through just a couple of quick multiple choice, just in terms of strategy, not really in terms of the material. So this one, okay.
Emily, I was going to jump in and let you know, we got about 15 minutes left. So for you.
Okay, we got 4 multiple choice. Oh, that sounds great. We're just going to, I'm just going to show you a little quick strategy for this. So when we take this, the derivative of this function using the product rule, right, it's u, which is x minus 1 times v prime. The derivative of that using the chain rule is 3x squared plus 2 squared times the derivative of the inside, which is 2x, plus v u prime, which is just 1. Okay, so I'm going to show you 2 ways. I'm going to show you the kind of the proper way to do this, and then the little shortcut way to do this. So once I have here, I'm going to show you, let's do it down at the bottom, how we would reduce this. So if I notice, I have an x squared plus 2 as a common factor. So I'm going to take that out, x squared plus 2. We have 2 of them. What am I left with in this first bit? I'm left with the 3. I'm left with the 2x, which is 6x. And I'm left with the x minus 1. Over here, I'm left with 1 of the x squareds plus 2. I factored out this. Okay, let's simplify this. 6x squared minus 6x plus x squared plus 2, which is here. So as you can see, here's my answer. But if I'm nervous on the test, rushing, not great with algebra, all these factors might make it very difficult to get from here to one of these answers. So I like to plug in a value for x. Here, I like to start with 0 or 1. 0 is probably the easiest. If I plug in 0 for x, right? So if I plug in 0, that's -1, that's 3, 0 for x, that's 2 squared. This is times 0, right? That's 0 for x, so that's gone. Plug in 0 for x, that's 2 to the 3rd times 1, which is 8. So I'm going to plug in 0 to all of these and see which one gives me 8. Plug in 0 for this one. 0 times anything is 0. 0 times anything is 0. I'm already eliminated 2 choices. Wonderful. I'm going to plug in 0 for this one. 0 for this one gives me, I'm left with the 2 squared. These are all 0, and that's a -1. All right, that's equal to -4. Doesn't work. Plug in for this one, 0. I'm left with 2 squared. Those are 0, 0 times 2. Oh, wonderful. That's 8. Want to check on my last one just to make sure. -3, I plug in 0, plug in 0 again. And luckily that one does not give me 8 as well. So I can get my answer that way as well. So sometimes you can kind of skirt these algebra issues just by plugging in a value for x. Start with 0, if not, go to 1. Right, this is kind of a popular concept. We want the function to be differentiable, therefore also has to be continuous. So remember, for a function to be continuous, the limit from the left has to be equal to the limit from the right, has to be equal to the value of the function at that point. here's where our function's switching. So first, basically think about the y values are the same. So plug in 2. 6c times 2 plus d, 2 squared minus c times 2. Right, we get 2c plus d is 4 minus 2c. I have 2 variables I'm not going to be able to solve, so I'm just going to leave it there. Now, for a function to be differentiable, that means the derivatives have to be the same. What's the derivative of the top? Cx is just c. What's the derivative of d is 0? Has to be equal to the derivative at the bottom, which is 2x minus c. And we're talking about at x is 2. So I can solve for c there. 2c is 4, divide by 2, we get c is 2. So if I plug my 2 back in, I'm able to get 4 plus d, 4 minus 4. So d is equal to -4. So when we have c plus d, we have 2 plus -4 or -2. So continuous, the y values are equal, differentiable, the derivatives are equal. Okay, this one here. So they were lucky enough to give you, I just wanted to go through a u substitution question because we haven't really touched upon that. So a couple of things, they gave you the actual substitution, which is pretty nice. So we have u is 1, sorry, half. U is x to the 1/2. So du is 1/2 x to the -1/2. I'm going to write that as 1/2 times 1 over the square root of x. And I forgot my dx here. dx. Now I can't forget to change my balance. That's like a big thing here, right? If we're changing into u and these answers all have u in here, we have to change the balance. So if u is 1/2 x to the 1/2, right? We go from x is 1 to x is 4. So when x is 4, 4 to the 1/2 is 2. When x is 1, 1 to the 1/2 is 1. There's my new balance. So I can eliminate, wow, 3 choices, great. So let's look back over here. So 1 to 4, actually I'm gonna leave the bounds off for now, just to, right? So we have e to the square root of x over square root of x dx. So if we notice, we have a 1/2, 1 over rad x dx, which is right here, but we do have a 1/2. Sorry, this is a du. So if I multiply both sides by 2, we get this. I'm able to replace this with 2 du, right? So that becomes a 2 du, and e to the x, well, square root of x, that's just my u, and my bounds are 1 to 2. So as you can see, we get 2 right here. Okay, we have one more multiple choice, which is the derivative of the inverse. Students tend to have a lot of trouble with this. So f, I like to put the points on the side. We know the point on f is 0, 1. If f and g are inverses, that means the point on g is 1, 0. That's how those work. So if we're taking the derivative of g at 1, that's 1 over the derivative of its inverse. But remember, it's not at 1 because the x value is not 1 on f. The x value is 0 on f. Those two change. All right. What's the derivative of f? I can do that here using our chain rule. 3, 2x plus 1 squared times the derivative of 2x plus 1, which is 2. So 6 times 2x plus 1 squared. So 1 over f prime of 0 is 2 times 0 plus 1 squared, which is 1 over 6 times, that just ends up being 1 squared. So 1/6. We get this answer here. They don't always give you this point. If they don't give you that point, what we're doing to find this 0x value is we're setting this equal to 1 and finding where it equals 1. This one is not as straightforward to solve, so they wouldn't really give you this one to solve, but they could give you like a function like 2x plus 4, and that you can solve. So remember, if they don't give you the point, you want to set your function equal to the x value here in order to find where we're evaluating our inverse function. Okay. Lastly, I just have a couple of topics that would be great to review in the corresponding pages in the book that explain them. If you are watching this after the fact, so it's a great place to pause, go check out the book, kind of go through these topics, see what you know, what you don't know. Here's some other topics as well. All right, and I guess we went through this online course summary.
You know, it'd be great if you could just keep it here for 1 second, make sure that everybody has.
Yeah, great.
Take a picture, jot it down. Before we move on, I wanted just to bring up not so much a question that was a comment by Kimberly earlier. She says, by the way, on one of your early slides, you said that 3.946 was not acceptable. I think it would be acceptable if students can truncate or round. Do you remember that, or do you want to respond to that?
Trying to think where that slide was. It's correct to 3 decimal places.
3.946, yeah.
Right, but that.
Kimberly, if you're still with us, if you could, maybe she can, and you could clarify that for us. And Rhonda is actually asking if we can go back to the slide before those questions.
Which slide? These ones?
I think I agree with Kimberly about rounding. So is it the 3 decimal places? Okay, this is the screen that Rhonda was asking for. And Kimberly is saying, yes, I think it's the student is okay if they round or truncate to 3 places.
3 decimal places?
Decimal.
Both are accepted. Wait, I liked my students just to keep it to 4 so you don't have any, there's no kind of questions with it. Maybe students, but both are accepted. Okay. I think she's talking about. Oh, back up here, I'm assuming.
Oh, there you go. Yeah.
Oh, okay. That you can truncate at 3. Okay. I had always just told them to keep it to 4 because I don't like there to be any margin of error. Yeah. So.
All right. Well, thanks for those. Emily, was there anything? I guess we can officially ask for questions now. I mean, they're already coming in. So is there anything else you wanted to say before we finished up?
I think that's it.
All right. Well, if anyone has any other questions or observations or anything in the next couple of minutes, we've got 2 minutes to go. Throw them in the chat or the Q&A. Emily, terrific job.
Right.
Really went through a lot of stuff there. A lot of really important material in a short amount of time.
Try to get everything in.
Yeah. Can you see that come through from Candace?
Yes. Okay, yes. All right, I guess I just like to usually play it safe. Thank you for the clarification.
All right, well, just a reminder, you know what, if we could go to that last slide that has the URL, the bit.ly for where the recording is going to be. Here we go. As we finish up, reminder that the recording will be live probably by tomorrow. Feel free to teachers share with fellow educators, students, share with other students. I think we can all agree that this was a really robust session with a lot of good tips good tips for the exam, reader tips, which I think are super valuable. So thanks again, Emily. Really
No problem.
terrific job. Yep. So one last question. Rhonda's asking if you can go back to the question before the inverse one.
For the inverse. This one.
I guess we'll just leave
Is
that
this
up.
the question?
Maybe she's up.
Oh, just need a picture.
She
Yeah.
wanted to take a picture. Yep. All right. Well, we're at the top of the hour. Let's give a couple more seconds, see if anyone else has any final questions or thoughts. All right. Well, thank you, Emily. Thank you, everybody, for attending. Good luck on the exam. And that's it. Take care.
Thank you. Thank you.
Good luck.